Yeah, to solve matrices.
I'm talking about an actual situation.
To solve systems. I don't know. I never use it.
An algebra teacher.
Yes, that's right. Once you teach advanced algebra, Kevin, then you'll use it. So we've learned multiple methods on how to solve systems. We know how to solve a system by graphing the two lines, finding the point of intersection. We know how to solve systems by using the substitution method. We know how to solve systems using elimination. We know how to solve 3x3 systems using the elimination method. Then we moved into the world of matrices, which we used row operations to solve systems. We learned how to find an inverse and use the inverse to solve a system. Yeah?
Is this continued?
No, that's the 2x2. Yes, this is continuing from 4.6. This is the rest of 4.6. So now what we're going to do is we're going to learn another method that we can use to solve a system. Now this is Cramer's rule right now for a 2x2. So we're going to have just an x and a y unknown variable. So if we have the following system, so you have your x's aligned, your y's aligned, your constants. We're going to use a sub 1 to represent the coefficient of our first x, a sub 2 to represent the coefficient of our second x. We're going to use b sub 1 to represent our coefficient of our first y, b sub 2 to represent the coefficient of our second y. And then c sub 1, your first constant, c sub 2 is your second constant. Now, to be able to use Cramer's rule, we need to check that our determinant of our coefficient matrix, this is saying right here, cannot equal 0. Because remember, if it equals 0, that means there is no inverse, and we can't use matrices to solve it. It's not going to happen. Okay, so that's what this is saying right here. So we need to always check that our determinant of the coefficient matrix, and we all should know what the coefficient matrix looks like because we use that when we solve for the inverse of the coefficient matrix, does not have a determinant of 0. If it doesn't have a determinant of 0, that means we're good to go. And this is what Cramer's rule tells us we can do. So right here are your x and your y variables. So once you do all of this, this is going to turn into some number, which is going to be equal to your x. Well, where does this some number come from? Well, what you're going to do is you're going to make a 2x2 matrix of your constants and of your b coefficients. And you're going to find the determinant. And we use the notation d sub x to stand for the determinant for the x. And then you're going to divide it by the determinant of your coefficient matrix. So remember, this comes from your coefficient matrix. That stays the same for both your x and your y. So you always will divide by your coefficient matrix determinant. So to find your x, you use all the numbers except for the coefficients in front of your x. To find the determinant, find your normal determinant, and divide. To find your y, you use all your numbers except for your coefficients in front of your y. Find the determinant of them. So we label that d sub y for the determinant of your y matrix. And then divide it by your coefficient matrix. So what we're going to do is we're going to organize ourselves by finding d. It's always the first thing you should find to make sure it's not equal to 0. Okay. We all know how to identify the coefficient matrix. Then we're going to split it up and find d sub x, and then we're going to find d sub y. Again, you do not need to memorize this. Okay. If I give you this, you should be able to pull these things and put them down in it, hopefully. Okay. So you should know that a's are the coefficients in front of your x's. You should know that b's are the coefficients in front of your y's, and you should know that c's are your constants on the right side. Is everybody good? Sure you are. Look how nice that looks. Look at that beautiful system. All right, so there's our system. 2x minus 3y equals negative 26, or 26, not 26. And then 3x plus 4y equals 12. Look how friendly that looks. So we're going to do Cramer's rule to solve this. Can we solve it by graphing? Sure. Can we solve it by elimination? Sure. Can we solve it by substitution? Sure. Can we solve it by row operations? Sure, we could. Okay, yep, we could graph it using your x and y intercepts would be a smart move. But we're going to use Cramer's rule. So the first thing you should always find when using Cramer's rule is your determinant of the coefficient matrix, which we are labeling as D. And I'm going to use straight bars because that means I'm finding the determinant of my matrix. So what is my coefficient matrix? 3, 4. Good. How do I find the determinant of that? 2 times 4 is 8 minus -9. Oops. So 8 minus a -9 gets us 17. So my determinant is 17, which is good. It's not 0, so that means I can keep moving on. And I used Cramer's rule. If it ended up being 0, then I couldn't use Cramer's rule and it would not work for me. All right, so now we're going to find d sub x, and then we'll have to find d sub y. So let's figure out d sub x first. What 4 numbers will make my d sub x matrix?
C1. So -26.
-26 and 12, right? I even have to make sure we're doing this right. So, yep, so my C's, my constants first, and then your B's, so -3 and 4. Good.
So what are we doing now?
Find the determinant of that. So 26 times 4, I should not be using my calculator, but that's okay. -104 minus -36. So -104 plus 36 gets us -68. We good there? So far so good? Now let's do d sub y. So what numbers will make up my d sub y? So it's your A's first. So 2 and 3, and then your C's. Nope, for y, it's for d sub y.
Then on this little graph thingy, what is the
Oh,
thing
then you do
below?
-26 and 12.
That's the d, that's what we're dividing by. So we're going to take d sub x and divide it by 17. Then we're going to take d sub y and divide it by 17.
Oh.
Stay with me. You'll see the beauty in a few seconds. 26 and then 12. So that gets us 2 times 12, which is 24, minus 26 times 3, 78, but -78. So 24 plus 78 is 105. So now we've got all of the information that we need. Huh?
Yeah, 105.
No, that's not right.
It doesn't look
I did
like
27.
your C's.
Thank you. It's 102. Say that again.
I was gonna.
What were you saying, Courtney?
Oh, no.
You're okay?
I was not good.
Okay. I just user error of the calculator, not the calculator's fault. Okay, so now we have all the 3 numbers that we need to make all of my ratios. So x is equal to what ratio? Put it up here. It's your d sub x divided by your d. So -68 divided by 17, which is -4. Huh? Your y is equal to d sub y divided by d. So 102 divided by 17, which is 6. So our solution is -4, 6. Is that less steps than row operation? Definitely. Okay, so it's kind of nice how it works out like that, but it's a matter of, do you memorize Cramer's rule for the rest of your life or not? I don't know. Okay, do we see how that works? All right, so how about you try one on your own? So using Cramer's rule, solve 3x plus 5y equals -5. -2x plus 3y equals 16. Try that guy out. So as long as we set up the determinants correctly, and as long as we can evaluate the determinants correctly, then you should make your ratios work out pretty well. Bless you. Okay. All right, we ready for the 3 by 3? Okay, so for the 3 by 3, it's even crazier. Because we have more coefficients happening. That's up to you. You're going to be given it, so as long as you can use it correctly.
It's literally the same thing.
So now we have our A's, we have our B's, our C's now become the coefficients in front of the Z's, and your D's now become the constants. Why?
I think you got it.
I know, I don't know why they need the C.
Like, just make it ABD. ABD.
So notice for the X determinant, they still keep the constants first, just like we did last time, right? And then we use everything but the X coefficient. So that's still the same as what it was for the other one. It's just now we have 3 more columns, or 2 more columns. So we have constants, we have the Y coefficients, we've got the C coefficients. To find your Y, it's still the same, except now it's a little bit different. So instead of just X coefficients and then constants, we're adding in the Z coefficients at the end of it. To find your Z, you take your X coefficients, your Y coefficients, and then your D coefficients. There's really fancy proof to get this, but I am not going to show it to you. It takes forever, and I probably will make a mistake trying to do it. So, to find your ratios, we're taking dx over d, we're taking dy over d, and we're taking dz over d. So it's just a matter of organizing our data, finding all 3 of those determinants along with our coefficient determinant, and then making the appropriate ratios. Okay? I'll wait for those people who are writing it down. Keep in mind, you will be given this, so it's not like you need to memorize it, as long as you can use it accurately.
Will be given that whole page there, or is it just going to be like the equations?
The whole thing.
Okay.
So, I give you the system with the coefficients, and then that. You ready for this action right here? That's your answer.
Why did we start with the hardest part?
What do you mean start with the hardest part?
the operation.
Because they're beautiful how they work out. They're not hard, they just take a while. And and you need to be very precise in your calculations.
You make one mistake and just put a whole thing and you're precise and it takes forever.
Right. The math isn't hard, you're just adding and multiplying. All right, here we go.
Oh, Jesus.
Forgot it already.
So we got x plus y minus z equals negative 2. 2x minus y plus z equals negative 5. X minus 2y plus 3z equals 4. If that got thrown into my face, the first thing I would be thinking is, let's eliminate those
Wait,
z's.
can we write that on the board and then go back to the?
Yes. So x plus y minus z is equal to negative 2. 2x minus y plus z equals to negative 5. X minus 2y plus 3z is equal to 4. All right, I'm going to do this on both so Andrew can watch this. Okay, so we've got to find, let's find D first. Find our coefficient matrix determinant. So we've got 1, 2, 1 for the coefficients in front of my x's. 1, negative 1, negative 2 for the coefficients in front of my y's. Negative 1, 1, 3. To find a determinant of a 3 by 3, what do? Rewrite the first two. Trying to keep yourself nice and aligned. All right. So, work through that, see what you get. -3, I got -3 too. So 2 minus 5 gets you -3. Yeah? All right. So our determinant for the coefficient matrix is -3. All right, so now let's find d of x. So dx starts with our coefficients, or sorry, not our coefficients, our constants. So -2, -5, 4. So now I got to go to our b's, which are our y's. So yeah, so 1, 1, -1, -2.
-1, 1, 3.
-1, 1, 3. So there is our d of x matrix. Let's find the determinant, rewrite the first two rows. Work through that. So I got 4 here. 4 here, so 4 plus 4 is 8. And a negative 15, which would be negative 7. And going the other way, right. Because this would be 6 and a 4, which makes 10. And then a negative 10, which would be 0. So we're doing negative 7 minus 0. Nope, you do this top left bottom right first. AD minus BC.
Zero minus 7.
So you did 10 minus 10 equals 0 is the.
Oh, I did it the other way.
Yeah.
So it'd be 0 minus negative 7, so positive 7.
Yeah, so I did the second one first also. I just flipped it.
Thanks.
So,
Yeah, ADBC. Okay, so we got that. So I'm just gonna write, so dx we said was 7, d is negative 3, so right away I can tell my answer is gonna be fractions, because those don't divide nicely. Now let's find dy. So dy is all of your a's, so 1, 2, 1. Your d, negative 2, negative 5, 4. Our c's, negative 1, 1, 3. So there's my y matrix. So repeat the first 2 rows. Find that determinant.
did you get, what did you get, Mr. Probably?
1, 6. I got negative 19. Alright. Maybe yes, I'm here to negative 15. Negative 2, which makes negative 17. And negative 8, which is negative 25.
If you always add them, you don't subtract.
Right. And then if we go this route, 5. Oh, I said this was, I missed that 4. That's 4. And then negative 12. So 9 and a negative 12 makes negative 3, so negative 25 minus negative 3. Yeah, so negative 22. Like that.
Oh, I'm gonna keep forgetting to minus a negative.
Yeah. Okay. Just need to get z yet. So dy is negative 22. Negative 25 plus 3. Now let's do z. So to find z, take our A's, so our coefficients of our, oh, I just erased that. That's right, we got it. So my A's are 1, 2, 1. 1, -1, -2. 2, -5, 4. -2. Thanks. Okay, so we'll repeat the first two rows. Find the determinant. -21. That's what I got. So -1 minus 20. Did you guys get -21?
Yep.
All right, so if we needed to find x, we're going to use d of x and divide it by d. Our d of x we said was 7. Our d is -3, so x would be equal to -7/3. Y would be equal to our dy, which we said was -22, divided by 3, so -22/3.
No, there's 22
Yes, because it would be -3, right? Negative divided by negative is positive. Thank you. To find our z, we're taking our determinant of the z, which was -21, divided by our d, which is -3, which is 7. So our answer, -7/3, 22/3, and 7. Okay, which is harder, I don't know. Elimination, it would have gotten a little bit funky because we had the two fractions in there, so it might have thrown us off a little bit. The math is not hard, it's just tedious to do it. All right, let's practice some. Grab some practice space, whiteboard, sleeves, whatever it is we want. Let's try it out.
We're gonna play the dot game.
No, we're not playing the dot game.
Dog, you get like 2 dots in by the end of the period.
No withdrawals.
It'd be like 2 dots a class.
I know.
I still want.
Yes.